So let's move ahead. Let's look at a Vasicek model. Vasicek model can be used to determine a regulatory capital and assess the counterparty risk by finding EL and UL. So basically, when you talk about a loan distribution, it also looks like this. And this is your expected value.
Mhm.
Okay, so there is one term called as a worst case default rate. So usually regulator gives you that check what is a 99% percentile value for this default rate here. Like
Okay.
you can just think of this as a Z value corresponding to this confidence level. So what is that level and difference between these two? So expected losses are your 50 percentile value. What is the loss that you are expecting? There is a chance that you will expect this much loss. But what is the difference between this expected value and this 99 percentile worst case default rate value that gives you the unexpected loss?
Okay.
Okay. And the model looks at the left tail of the distribution. So it looks at this distribution. Unexpected loss is defined as a worst case default rate minus probability of default times this is the same. Over there,
Mm.
you just had till this much. Now the PD get replaced by worst case default rate minus probability of default rate times your remaining terms.
Mhm.
Okay.
Yeah.
Now, like, how do
That's
you
a
cal
formula. Is that the formula for Vasicek
for?
model?
Yeah, this is a formula that I'll be walking you through. So to
Can I
calculate,
just write it now? I just write it
yeah,
down.
yeah, just
So
the
Vasicek model is also determine the unexpected loss.
Vasicek model determines yes unexpected loss. Yes.
Oh, unexpected loss is equal to, usually the unexpected loss is actual loss minus expected loss,
See
right?
that's absolutely correct. But way to think at it is
No,
like
I'm just
yeah,
thinking,
yeah,
just giving
that's correct. But when you talk about
loss.
you we cannot wait till actual loss has happened. I want to estimate what is the estimation. Okay.
Mm.
So I mean I cannot wait till actual loss and think
Choices.
that I will calculate unexpected loss later. So that's where I want to estimate unexpected loss also.
You want to estimate the unexpected loss, so you still have your okay, you still have your
Worst case default rate.
the expected loss parameters here. Okay, okay, understand. WCDR is
Default
uh,
rate.
worst case default rate minus
Mm.
percentage of probability of default into EAD into LGD.
Yeah.
Okay.
Okay.
Okay. Formula just keeps on adding, adding, adding.
Yeah, in fact, that is not a great formula. This is a, I mean, great formula to calculate the worst case default rate.
The
I
one
mean, the
n
actual,
minus one PDR.
yeah, actually, this is a real formula that's tricky. That these are trivial formulas. I won't even, these are quite trivial formulas. I won't even bother. This is something wherein I will need some help from my memory.
Mhm. Okay.
Okay. So this is a formula that gives you this WCDR.
Oh, so
Okay.
WCDR formula is this one, huh?
Yeah, I mean that's in fact if you in fact I was wondering that you were bothered about this formula. This is quite trivial, I would say.
No, the
This
thing
is
is,
the
I'm not
yeah
bothered that in isolation. I'm
yeah
just
in
bothered
general
because
totality
that
totality.
already I just remember this the previous one PD minus PD square by all those things, right? Just
See
yeah,
in that I would say that don't bother
very
about
little.
alpha much, but yeah just
Sigma.
remember that sigma is sometimes maybe useful. Not if not directly, somewhere directly you may use it.
Yeah, yeah.
So
I'm just thinking like all those things. Yeah.
yeah, yeah. Connect the
Mm.
dots and I understand time is biggest
Mhm.
constraint here. That's why it may be giving you
Yeah, that is the main thing. Otherwise, these things, when you go through for the fourth time, you know what it is.
yes, absolutely agree, yeah, yeah. So
Okay.
we have to calculate this and
Oh my
so
God.
when I so now be very careful. So when I
How to
look at
remember this?
uh I would say that just write first few parameters. First get rid of this under root 1 minus correlation. Do the
Okay, one.
brackets, write n.
Okay.
And in first,
minus correlation.
n inverse of
Then
PD
n
plus
inverse of PD. Yeah. Okay.
under root of P, n inverse of your quartile, that 99%. So 99.9.
Okay. Again, n inverse of 0.99. Okay.
0.99 is your 99% confidence that I talked about here. That you want that to WCDR to be
Okay.
99.9% sure.
WCDR is
That's why we
equal
are
to
calling it as a worst case, because I want to be 99% 9 sure that what would be my loss.
okay n first and n inverse of multiplied by PD, right? I
N
can't even
inverse of PD.
I can't even write this. And then root of P. Okay. And again n inverse. And that is n inverse into zero point 0.9 or top 0.9 into, right?
No, no. So that's what I was explaining. So when you talk about n inverse of x, this is a function.
That is n
So
inverse of PD, correct? That's the same thing. That I think that is quite
yes,
clear.
yeah,
Plus root of P n inverse of n inverse
99%.
same as PD, right? Same as the
Yes,
multiplication.
yeah, yeah,
Oh,
yeah.
okay, okay. And
No, not really multiplication. It's not a multiplication. In fact, write the formula,
oh,
then I'll explain.
okay, okay. Understood what I mean. Okay.
So can you tell me when I talk about, say, I'm good going bit basic. Can you tell
Mm,
me if I talk about f of x is equal to x square?
yeah.
If I talk about f of 2, what would be my f of 2?
4, 4.
2 square, right? 4.
Yeah, 4, 4. Yeah.
So in a similar way, I can talk about this. So and what would be f inverse of x? So this is f of x. What could
Mm,
be f inverse of x in this case? So if my y equal to x square, if
minus
I
1 by 1 minus 1 by 2 square.
no, if my y equal to x square, how do I calculate y?
Yeah, y x into x.
So
X into
I
x.
will,
X.
if I want to find x, I am given y. I want to find x. So I'll just take a root of y.
Yeah.
If I'm given y, I will
Mm,
just take a root of x. So
yeah,
I
yeah.
will find x.
Yeah. Yeah.
So if I talk about f of x, it is x square. Then my f inverse of y is my root x, or other way around. Like if I want to talk about this, x is equal to f inverse of y. In the same way, like
Mm,
inverse function is root x. So square and root are both inverse function. In the same way, e to the power x and ln are inverse function. So over here also we talk about n of x and n inverse of x. So
mm,
when you talk about n of x, you are given a z value and you are trying to find a probability. So when you are given a z value, you are trying to probability, that's a n function.
mm,
Okay. And when you are given a z value, sorry,
mhm.
when you are given a probability, like in this case, you are given a probability.
Okay.
When you find n inverse, that means you are trying to find a z value.
Okay.
Are you following? See this table. So if I'm given z value and if I'm
Okay.
finding the probability, that is a direct function. So I'm finding n of z, that gives me some probability.
Okay.
When I'm calculate n inverse of probability of default, that will give me the corresponding z value. Some
Okay.
sense, making some sense.
Yeah.
So in the same way, I have got this formula. I will use this to calculate what is the worst case default rate. So let's take some pair. So let's talk about this pair, probability 1.5%. You can fill entire table or you can just at least solve. I'll solve one here.
Okay.
For one pair of PD and correlation, I'll find a WCDR for one pair, any random pair you can pick and try to find. I think, given the entire table, how do you fill it? But you can just give a try. How do you find one? Shall we?
Mm,
Okay.
yeah.
So let's talk about when your PD is 1.5% and say when your correlation is 0.4. I'm considering this pair 0.4 and 1.5%.
Mm,
So let's see what my WCDR is. So I will proceed with the same formula, n of, as I said, under root of 1 minus 0.4. So it would be under root of 0.6.
Okay.
Okay. And now n inverse of PD. In this case, PD is 1.15. So n
1
inverse of, so I will find the corresponding Z value for this one. Okay. In the same way, under root of 0.4 times n inverse of
0.99.
0.999. So let's see what it is.
How do we calculate the n inverse?
I'll show you. First of all, can you tell me what is the root of 0.6? Let's try
One
that in
second.
the
1 second. 0.6 root 0.7745.
0.7745. Okay. Now let's see. Now be very careful. Uh, I want to find probability that it is 1.5 Z value, wherein my probability is 1.5%. So somewhere on the this Z value, I want to find. Okay. But be very careful. In my table, I may find some value from here. So sometimes you are directly given a Z value corresponding to 1.5% you can use. But in usual tables, what you will be given is probability of this entire 98.5. So Z value corresponding to this would be given. We will take a mirror image. We will apply the negative sign. So if Z, this is a Z, I will apply minus Z over here and we will use that minus Z here. Does it make sense?
Yeah.
So let's see. Now you tell me what is the probability of 1.5%? As I said that 1.5% is not directly in the table. So you can look for Z value corresponding to 98.5% probability. Where do you see 98.5% probability in the chart on the right hand side?
98.5 percentage probability. Yeah, somewhere there. Yeah. 0.07, 2.17.
So 2.1 and 7. So what
Yeah.
I'll do, I will write it as a minus 2.17. I mentioned the reason because this is 98.5% probability. What I am looking for is 1.5%, which would be quite on the left hand side. So what I'll do, I will mention as 2.17.
So the since we are talking of n inverse, we just went to the 100 minus 1.5, 95 percentage, 98.5 percentage, correct?
See, if you are given table like 1.5%, you can directly take over there. But usually table would be like this, wherein you have to take 98.5 and
The
apply the
reason why
minus.
we are taking 98.5 is because of n inverse or what?
98.5 because I don't have in table, it's 1.5%. So 100 minus 1.5 is 98.5 because in my table, this kind of convention is there in the table. So I
Okay.
want to convert somewhere on the higher side, 50 plus value. So I would subtract it from 100 minus, it would give me this value. Now, can you tell me a root
No,
of point?
I'm trying to understand the purpose of the n inverse. How do we calculate that n inverse? Oh, n, okay, maybe I'll put it other way. N inverse of 0.0015, correct?
Mm-hmm.
So if n inverse was not there, correct?
Mm.
Just n of 0.0015.
Mm.
In that case, how do we do?
See, in that case, what you will do, you will see what is a 0.01, like that even
Um,
not exists. So that
exist
is a Z
understood.
value.
So since we call it as n inverse, instead of looking at that rows and columns, we are looking for that existing. We are looking for the value within the table. Correct?
Yeah,
Since it's
yeah,
an n inverse. Okay. And
yeah.
from there, it's 98.985 and the corresponding one is 2.17. And the reason why we are making it as minus is,
Because I am looking for 1.5. Table
mhm,
gave me 9 for 98.5. So best
okay.
way, these are mirror images. 1.5 and 98.5 are mirror. So this is a mirror at 50 percentile. It's normally distributed. So these are mirror images.
Okay.
Okay. And what you were asking is n inverse, if you would have like to calculate n. So we
Mm,
have that here. So
mm,
after calculating this entire bracket, we will
mm.
find n of that also. So we will get to know how do we look that value also. Are
Okay.
you following me?
Yeah, yeah.
So over here we have n inverse. Inside the bracket, we have got n inverse, but outside bracket, we have got n. So after calculating this bracket, we will anyways look n also. So you will get some sense out of it.
Okay. Okay.
So as I said, n inverse of x gives you the z value and n of x gives you the probability.
Okay. Then what will give the probability?
N of
Yeah.
x. So n of x will give you the probability. N inverse of x will give you the z value. Output of that function would be z value.
N of x is probability,
Hmm.
and n inverse of x is the uh, what did you mention? N inverse of x is what?
Z, Z value.
Z value.
How
And
many
Z,
standard deviations are you far from the mean?
and that is the 0.98 whatever we saw there. That's an inverse of x. Oh, that
That
is a probability. That's a
so
probability.
x is your 98.5 in that case. When you apply n inverse, that means you are finding the value of z. So
Okay.
value of z is 2.17 in that case.
Okay.
Okay. Now help me with the value of root 0.4.
Point point not two, right? Okay, just give me a second. 0.632.
0.632,
Yeah.
6324 into, now you have to tell me n inverse of 0.999. First of all, do I need to do 1 minus in this case? Like how I did for 1.5%? Do I need to do one
Yeah.
minus something? Why? Because I have directly got bigger value here. So I can see directly 99.9. When it is a smaller value like 1.5%, then it's a value. Table does not give you that value. That's why I converted into some bigger value. And I did the mirror image. It's quite little logical. I mean, if you understand
One
normal
second. One
distribution.
second.
Yeah.
0.99 is a smaller value.
0.99 is a 99% value. It's a big value. So I can directly see on this side. 1.5% was a smaller value. So when I was talking about 1.5% value, it is a smaller value which I cannot directly see from the
and,
table.
and 19% on the right hand side, rightmost side.
99.9 is very on the higher side. It will directly can be seen in the table. So tell me, what is the Z value for 99.9%?
Point what is it? 0.99, right?
Yeah,
So you can see 0.9 and 3 deviation or 3.08 or 3.1.
3.1. Okay. So what I'll do, I will plug in 3.1 here.
And
Is
we
it
don't do
making
the
sense?
minus. No, actually, no. This one I'm clear.
Hmm.
1 minute.
Yeah, and your
0.999.
question was correct. Why not minus? Can you tell me?
1 second. This we found. Can you swip to that table? We looked at the Z table and then we found 0.9990 here. Last time we were doing the, since it's a very small value, 0.0015, because it starts only from zero point 0.5,
Hmm,
right?
hmm, hmm,
This
hmm,
starts only from zero point 0.5. If it's anything between zero point 0.5 and 1,
hmm.
then we'll be able to
0.50.
find 0.50.
Yeah.
Okay. zero point 0.5 and 0.998. 0.5 and 0. Okay.
So
Uh,
anything left of 0.5, what you have to do, you have to do 1 minus, take some Z value and apply the minus when you are getting output. So
Correct,
that
correct.
will
That's what
give,
I'm saying. So 0.5 to 1, we have the value. So we can just plug, if the value is greater than 0.5, then we can just take it from there.
yeah,
Correct?
yeah,
If
that's
it's
correct.
less than 0.5, that is what you're saying, 0.0015 and all, it's less than 0.5.
Yeah,
Then what you have to do is you have to go and find the corresponding 0.0015 in the probability table and then do a and then do a minus,
yeah,
and then do a minus of it.
yeah,
That's what we did, correct?
yeah, yeah. So
Okay.
now can you do this calculation for me? Just multiply 0.3624. I think it's already on your screen.
Yeah.
Multiply it with 3.1. Store that in your first memory slot.
Okay.
Okay. Now, or just add or subtract minus whatever you got it.
I already
Uh,
stored it in the table
yeah.
now.
So
No
recall
problem.
one. Recall one
We call one
minus 2.17.
minus 0.20. Is it correct?
Minus 0.209 divided by 0.7745.
Minus 0.2093 divided by 0.7
7745
minus 2 minus 0.2703.
divided by 0.7745 minus 0.27.
Yeah, minus 0.2703.
Okay. Now, what is a probability where my z value is minus 0.7? So somewhere here, like just hypothetically, there would be some z value called as a minus 0.27, and it would be this value. So
Hmm.
this area under this curve, I mean, there would be some z value, or there would be some z, which value would be minus 0.27. I'm trying to get the
Yeah.
area under curve till that z value.
Hmm.
So when I say I'm trying to calculate n for the value inside it, I'm trying to calculate the probability. So when I calculate n of x, it gives me the probability.
Yeah.
Okay, so now let's see how do we calculate minus 0.27. Can you tell me if my table has 0.27 value?
No,
So what I'll do, I will look for 0.27, positive 0.27 value.
that is also not there, right? Because it starts from
It's
0.5.
there. It would be, that is a probability. Z value starts from the zero. So
Okay.
probability starts from 0.5.
Mm, mm, mm,
Okay,
mm.
this is a Z value.
Okay.
For Z value also, what I'll do, I will look up for the positive Z value. So what is the probability till this Z value? Subtract that from 1. So let's see what is the probability corresponding to 0.27. So this, what you were referring to, this is, you are referring to this. So this is a
Probability.
probability zone. I'm
Probability.
referring to Z zone. This is
Understand.
a Z value on the header vertical and on the first
So,
column.
so we
So,
got 0.6064. So 1 minus 0.6064.
so 1 minus 6064. Yeah, perfect. So this is a value that we have to refer. So 1 minus 60.64. Can you do 100 minus 60? Because this is a Z value corresponding to 0.27. What I'll do, I'll calculate the Z. So this would be equal to 1
Wow.
minus n of 0.27. You can write in this way. So 1
Mhm.
minus 0.6064. Can you tell me what, how much it is? It is around
0.3936.
39.36.
3936.
Yeah,
Yeah.
3.936. So this is a value for this pair when you have probability of default as 1% and correlation is 0.4. Let's see if we are correct.
Yeah.
So 1.5% and correlation. So some rounding off issue, but it's 99%.
So probability of default, 1 point for the loan. This is a portfolio, right? This is
Yeah,
a large portfolio where the probability of default of the entire portfolio is 1.55
yeah,
percentage,
yeah.
and the correlation P is what? Correlation or
Correlation. Correlation of underlying credit. If one loan
okay,
defaults, how
correlation
it will impact on the
impact the
default
other.
of other loan.
So one asset or one loan.
One loan.
Okay, so
So
it is a combination
correlation
one
of,
one loan with another loan.
yeah, that's correct.
Okay, so what will happen if there is a probability default for the entire portfolio of 1.5 percentage, and probability of coefficient or probability of the correlation between the loans among the loans is zero point 0.4, then probability of default is 39 percentage.
Yeah.
Worst case default, worst case is
Worst
30.
case default rate. Yeah, 39%.
Okay.
So you can imagine, you can just even think, usual probability or default is 1.5%, but your worst case default is almost 40% chance.
Oh,
So,
okay.
so that's
Mm.
how you can think of it. But you might be thinking that, oh, I spend a lot of time on this calculation, but trust me, the tricks that we had here, it will help you scoring some marks on normal distribution and hypothesis testing also, because sometimes these tricks, minus and pictorially, whatever I was explaining.
But only thing is like n inverse and n I'm still not very clear. For example, if it's here we took n as minus 0.27,
Hmm.
correct?
Mm-hmm.
Let's make it very simple.
Yeah, yeah.
N of minus 0.27, what we did, or n of 0.27. Let's take n of 0.27. So what we are doing is n of 0.27 is the z value of 0.27. What is the probability?
Yep,
Correct?
that's correct. Absolutely.
That's
Yeah.
correct. So
Yeah.
can you go to the screen? Can you go to the yeah. So we go to the Z value here and then look at 0.6064 would be the n of 0.207. What would be the value of n inverse 0.27 here? That was what my confusion. N and n inverse. If n,
See,
what would
I will answer your question, but don't be very careful when you are, because if you keep thinking, that may sometimes give you a problem. So if I were to calculate n inverse of 0.27, that means I have been given z value. I want to find the, so it's other way around. So when you calculate n of z, it gives you the probability.
correct? I understand. This is very clear.
Okay. So
Mhm.
and when you calculate the n inverse, in that uh you are given the probability under this,
Got it. And
and you
you have
have
to
to
find the
calculate
find
z
the yes,
value.
that but clear.
So
Now it's
now
clear.
you are given 27%,
Okay,
and you
okay,
have to
okay.
find the z value. So do you see
So
27% in the table?
so n will take the z value, n inverse will take the probability value.
Yeah, so be very careful. If you are given z, if you want to interested in corresponding probability, then you apply z, n of z. When you are given n inverse of probability of default, you have to find. It's little tricky. I see your difficulty area,
Mm,
but
mm.
sometimes like keep answering. So can you tell me how I can calculate n inverse of 0.27 now?
Okay, n inverse of 0.27, that is a probability, right? So it's like 27% the probability. So we can go here and then see 0.27. It's not here. As we said
Hmm.
already,
Hmm.
between for 0.5 and 1 is
Let's
what?
take
Let me
25%.
complete. Let
Let's
me
take
complete.
25% for simplicity. I'm making your
Okay.
life easy.
Yeah,
Yeah.
25 percentage. Now we don't see that here. So 1
Hmm.
minus, we just do the 1 minus
Hmm.
0.25, that is
Hmm.
0.75,
Hmm. Hmm.
and then go to the 0.75 here,
Hmm.
which is somewhere 0.07 or zero point zero 0.08. Okay, 0.67 or 0.68, just say 0.67 or 0.68.
Hmm.
0.68, 1 minus 0.68, which is 0.32. That's a value.
So be very careful. When yeah, I see your difficulty area now. When you calculated the n inverse of 0.75,
Mhm.
you found some z value, say zero point 0.6 for sake of simplicity.
Mm.
Okay, in that case, you don't have to one minus. In that case,
Just a
you just have
minus.
to apply
Minus.
minus. That's the trick.
Mm,
And that will be only clear when you try to visualize pictorial things.
mm.
If you try to set some rules with equations, sometimes there would be, I mean,
Confused,
it
yeah.
get, yeah.
Mm.
So I would strongly suggest visualize graph. When you are calculating Z value from the table, it's just a minus or plus. It is not one for one probability, it's one minus.
Mm.
I understand there is a trick, but like
Mm.
logically, you have to be clear. There is no thumb rule you can think of. Otherwise, small.
Logically, how do you say that? Can you just explain? I know you explained. Can you just one more explain on this?
So so probability corresponding to Z value, so probability corresponding to, so n of say PD equal to Z. So n of 1 minus PD, let me write in this way, is
Minus it.
minus Z.
Yeah.
Okay. So other way around, like in this case, like you can just remember this equation in case if that
Mm.
helps.
Yeah. Mm.
Okay. But I would suggest that just keep a pictorial representation. I see your difficulty area. I mean, I completely get that. But be very careful when you are calculating the Z value.
Can you go there? Can you go that equation? 1 minute. N of probability is equal to Z. N of 1 minus PD is equal to minus Z. Okay. N of probability distribution. Probability N of probability distribution is Z. So probability distribution, for example, 0.74 is
Hmm,
0.607,
hmm, hmm.
0.67
Yeah.
probability distribution. But when you want to take N of 1 minus zero point 0, okay, I think I got a point to an extent.
Okay. So this is something when you calculate Z value, and
Okay.
very careful, Z value will be required only inside bracket. So when you talk about outside bracket, it is a a probability for, so you, inside bracket, when you have got probability, you are trying to take n value, you calculate the, so you are given a z, if you apply n on that, in this case this bracket term will give you some z value, you have to find n of that, it will give you some probability, like this how we got 40%.
Okay.
Okay,
Yeah.
just I would suggest that at least try 2 pairs from this.
Just go back. Just go back. What you're saying is n will give you the probability.
Mhm.
N inverse will give you the z value.
Yeah. So inside your brackets here, like worst case default rate, we are trying to calculate the z values. We are given some probabilities. You see probability of default here. You see 99% 9 probability is given. You are calculating inverse of probability. That means you are calculating the z value.
Okay.
Okay.
So from
So
probability, you calculate the z value, and using the z value, you're again calculating the probability.
probability, yeah, yeah.
Okay.
You can just do one more pair, like say
Yeah, I will do
homework
that.
0.6
Yes.
and 1% or 2%. Say 2%, PD as 2%, and correlation as 0.6. You can take this as an exercise and try to match answers. It's already given here. So you can just do one or two more. It will make you comfortable.
Yeah,
So
it's going to take
okay.
time consuming. Yeah.
Yeah, but it tells me if you are very comfortable with even this bracket calculation, it can earn you 1 or 2 marks in the normal distribution also, for sure.
Okay.
Okay.
Why you say normal distribution?
Sometimes you are given like this kind of calculation is given, like you are given some z value, you are asked to calculate, or you are given some probability, you are asked to calculate what is
The
uh
z value.
yeah, z value, or this calculation can be asked in isolation also, and only crux of that is this whatever your confusion area was. So if you are comfortable with this calculation over there, by default you will earn 1 or 2 marks.
Got
Some
it.
definitely they will
In fact,
ask.
in fact,
Yeah.
this was one of the question I wanted to check with you. I remember I was like 4 days ago, I was saying I have some basic doubts.
Mm.
The basic doubt was about the z value and the probability.
Mm. Yeah,
Now
I think.
I think I think it's just quite clear. I need to go back and then look at some of the problems in chapter 2.
Yeah, yeah, sure. It will resolve your this issue.
At least now I know the z value inside is probability, and the n value of the z is a probability given. And if you want to calculate the z value, I want to look at the probability and then take a minus one minus or minus what. I think I got the point.
Yeah, good.
Yeah.
Same thing. So credit metric model. The credit metric model is used to determine the economic capital.